Hello everyone, my name is Ksenia Zaytseva and I'm data architect and software infrastructure developer. I'm here today to talk to you about control vocabularies and SKOS standard. In this presentation, we will talk about control vocabularies and how they are used in different domains. I will give an overview of SKOS standard and examples how it's used in data management systems. We will also talk about interoperability of control vocabularies and how they impact search performance in information systems. I will explain how to create your own control vocabulary for your research project and what open source software and tools you can use for this. In the end of this presentation, I will give a few practical tasks to test your knowledge of vocabularies and SKOS. Let's begin with the definition of control vocabularies. Control vocabularies are knowledge organization systems that contain structured set of concepts or terms for organizing and classifying data in order to ensure its future access and retrieval. The terms are data descriptors that used to distinguish and define the characteristics of knowledge resources in a specific domain. Patricia Harpring gives the following definition, saying that control vocabulary is an organized arrangement of words and phrases used to index content and or to retrieve content through browsing or searching. It typically includes preferred and variant terms and has a defined scope or describes a specific domain. There are many different types of control vocabularies. The most common are Thesauri, classification schemas, subject heading lists, taxonomies, terminologies. Depending on the research goals and data requirements, one or another type is used. Control vocabularies are prominently used in many domains of research and industry. On the web, vocabularies are often used in building the information architecture for websites, data repositories, or information systems, thereby providing terms for indexing and retrieval of information objects. Control vocabularies are widely used in biology for classification of living organisms. Public health and medicine have vocabularies in various forms for defining categorizations and classifications for biomedical investigations, diseases, symptoms, medical errors, and other. International organizations actively use control vocabularies to standardize terms and translations in international affairs. The most notable examples are the United Nations terminologies that are translated into 6 main languages of the United Nations to eliminate ambiguity in terms used in international communication. Galleries, libraries, archives, and museums use control vocabularies for a very long time to describe their objects and resources and build catalogs and information systems. The fields of computer science, such as data mining, knowledge extraction, or conversational AI, use vocabularies to classify entities and objects in text or speech recognition. We can summarize that control vocabularies used to organize large volumes of data for future retrieval and search, to simplify user experience and navigation on the website, and to facilitate an exploration process in information systems. Vocabularies are used to reduce ambiguity of human language and bring a common understanding of used terms within a defined context. In research, vocabularies are widely used within open data and open science initiatives for data integration in order to allow large-scale data analysis and datasets discovery. Control vocabularies are also used as a base for recommendation and question answering systems. This diagram shows an example how control vocabularies are embedded in architecture of an information system. In this example, the archaeological site is a universal abstract class, whereas Athens is an instance of archaeological site class, and the particular that represents the real archaeological site. Archaeological site related to a research activity that was performed at this specific location. Each research activity can be described by its type. Those types are terms in control vocabulary. In this case, a research activity can be of type, for example, excavation or field survey. So how do we model our control vocabulary and express it in a machine-readable way? For this, we would use SKOS standard, which is a World Wide Web Consortium recommendation developed for representation of any kind of control vocabularies. SKOS stands for Simple Knowledge Organization System and is a common data model for sharing and linking knowledge organization systems on the web. SKOS is a part of Semantic Web Standards and based on Resource Description Framework. There are two documentation guides for SKOS. The first is informative guide and it's called SKOS Primer, and the second is normative guide, which is intended for users who have a good understanding of semantic web technologies, especially RDF and OWL. I would recommend to read both because they contain all information which is needed for work with SKOS vocabularies. Let's talk about SKOS syntax and SKOS structure. The central element of SKOS is a concept. SKOS Primer defines that concepts exist in the mind as abstract entities which are independent of the terms used to label them. To create a concept, we need to create a uniform resource identifier and assign this URI with RDF type SKOS concept. This is an example how it's done in RDF syntax. URI example cat has RDF type SKOS concept. In SKOS, each concept is defined by a label in natural language. SKOS provides three different properties to attach labels to a concept. The first is SKOS pref label. This is a preferred label for a concept in a given language. SKOS allows only one unique preferred label per language. That means that one concept cannot have two or more preferred labels in one language. The second is SKOS alt label. This is an alternative label for concept, and it's used to store concept synonyms, abbreviations, or acronyms. The third property is SKOS hidden label. It's used for capturing misspellings and other spelling variants of concepts labels. This is an example how the concept of cat is assigned several labels in different languages in RDF syntax. SKOS provides two types of relationships between concepts that can be established in a vocabulary. First type is hierarchical relationship. This relationship can be expressed via properties SKOS broader and SKOS narrower. SKOS model doesn't state that broader and narrower are transitive, but it also doesn't imply that these properties are intransitive. And here is a little note on transitivity and what is transitivity. The relationship is transitive if concept A is broader than concept B, and concept B is broader than concept C. That implies that concept A is broader than concept C. If one wants to explicitly state that the relationship is transitive, then they should use transitive properties like SKOS broader transitive and SKOS narrower transitive. And the second type of relationship is associative relationship that established with properties SKOS related. And this type of relationship is not defined as a transitive property. This means that if concept A is related to concept B and concept B is related to concept C, it doesn't mean that concept A and concept C are related. It's important not to mix hierarchical and associative relationships. If two concepts are in broader, narrower relationships between each other, then they are explicitly in hierarchical relationships. Therefore, they don't need to be related to a SKOS-related property. Similarly, if two concepts are related via SKOS-related property, we can infer that they are related in some other distinct relationship. For example, a concept representing a tangible object is related to a concept describing a method that uses that object. And here we have an example of semantic relationships between two concepts in RDF. Concept of cat has a narrower concept wildcat, and concept of wildcat has a broader concept, which is concept of cat. Now we will talk about how we can document our concepts and their management process. SKOS defines properties to add human-readable documentation about each concept, and I strongly recommend adding such documentation properties to each concept when creating a vocabulary. There are several properties that can be used for this. SKOS note is generally used for general documentation purposes. Scope note used for storing partial information about the intended meaning of a concept. SKOS definition usually contains complete explanation of the intended meaning of a concept. SKOS example property is used to provide usage examples of a concept in a specific context. SKOS history note stores any significant changes to the meaning or the form of a concept. SKOS editorial note is used by editors to log any administrative information about a concept. And finally, SKOS change note is used to describe changes for the purposes of administration and maintenance. This is an example of documentary notes in RDF syntax. Our concept of cat now has editorial note, change note, and definition. For representing the notion of a control vocabulary itself, SKOS introduces a concept scheme class. Basically, this class is used to organize concepts together within an explicitly defined scope. To properly associate concepts within a concept scheme, all concepts must be linked to a concept scheme using SKOS in-scheme property. Top-level concepts that are entry points of hierarchy have to be linked to a concept scheme using SKOS top concept of or SKOS has top concept properties. Each concept scheme also can have a set of metadata properties that describe its creators, contributors, access and usage rights, licenses applied to it, and other things. For this purpose, Dublin Core metadata standard can be used or any other preferred metadata specification. This is an example of concept scheme RDF statements. Here we have a control vocabulary with the title Animals Vocabulary, and it has one top concept, animals, and RDF statement about animals concept states that this is a top concept of animals vocabulary, and this concept is in scheme animals vocabulary. Besides arranging concepts in one concept scheme, SKOS provides a class of collection that is used for grouping concepts based on their shared characteristics. Concepts can be added to collection via SKOS member or SKOS member list properties. This example shows how different concepts representing wild cats can be grouped in a collection of wild cats in Europe. The geographical location in this case is a common characteristic by which we group concepts together. Additionally, to creating relationships among concepts in one vocabulary, SKOS provides properties to reconcile concepts in different concept scheme or linked open data resources on the web for the purposes of data interoperability and integration. There are several types of match properties, for example, exact match, related match, broad match, and others that can be used for this. This was the last part about SKOS and its structure, and now I would like to talk about the quality of SKOS vocabularies and what common errors can be avoided when building a vocabulary. Since the future retrieval and search functionality will directly depend on the quality of control vocabulary, therefore it's important to follow SKOS recommendations and check a vocabulary against the most common errors before using it in your web application or publishing it. The most common bad practices include omitted or invalid language tags, label conflicts, for example, when two concepts have the same preferred lexical label in a given language and at the same time they belong to the same vocabulary. It also includes the cases when concepts don't have any associative or hierarchical relationships within a concept scheme, or when concepts are not documented at all. Among other bad practices are those when concept scheme doesn't have any top-level concepts, or top-level concepts have broader concepts in the same vocabulary. And this practice contradicts the logic and definition of a top concept. So I really recommend you to check your vocabulary against this checklist before the official release. Next, I would like to give you a few examples of how control vocabularies are used in database design and are part of information architecture in the user interface. In this example, control vocabulary values are used as database values and displayed in the user interface during data curation or annotation process. They can be used as drop-down lists or autocompletes. For example, when we create a record of an object in the user interface, those control vocabularies can be used as drop-down options. Next example is the context information in the user interface. In this screenshot, the SKOS values are fetched when user hovers mouse over the research method name. It shows the user the definition of this research method and its translations in other languages that are used for data annotation in this specific international project. And probably the most common example is the faceted search, when we filter objects in our database based on the control vocabulary values. This is the most common application of control vocabulary in information systems and data catalogs. I'm pretty sure each of us use this type of search when searching for a book or article in library catalog system. Another very important application of control vocabulary is its usage in linked open data, where control vocabularies are used for connecting distributed datasets via concepts persistent URIs. Since each concept has a unique, stable, and resolvable URI, it can be reused by other projects to refer to this concept. The reference can be done by using directly URI or by retrieving a URI using the API of a vocabulary service. And on the slide here, this is a screenshot of the Iron Age Danube Thesaurus in SKOS vocabulary repository that's hosted by the Austrian Center for Digital Humanities and Cultural Heritage. This is a user interface, but all concepts from SKOS service can be also retrieved using SKOS API. Previously, I already talked about how control vocabularies are important for data integration, and now I would like to discuss several approaches for making vocabularies interoperable. The first approach is the simple case when the data from different data providers is annotated with a set of pre-selected and agreed upon control vocabularies. This ensures that the data can be aggregated and used for data analysis very easily because most likely it won't require any further data curation. Another approach is applied when different projects and data providers use their own project-specific control vocabularies. In that case, the vocabularies can be linked to each other through established relationships among concepts in them. The linking happens on the level of a concept description when we add an RDF statement that the concept is, for example, exact, related, or close match to a concept from external vocabulary or from a larger semantic network like DBpedia or Wikidata. And the third option is to use meta vocabulary for linking local vocabularies and establishing relationships among them through common meta-level concepts. The backbone thesaurus is one of the examples in the digital humanities field that has as its purpose to allow interdisciplinary control vocabularies development and integration. And now we start the last part of this presentation, where we will talk about how to create a vocabulary and what tools use for this. The process of creating a vocabulary starts with defining the scope of your data. This will directly depend on your research goals and questions. After that, you have to structure your data and perform some conceptual thinking. It's usually the most time-consuming stage. It's often an ongoing process and can last till the end of the project. At this point, you would structure your terms in SKOS model, create and agree on concepts definitions, translations if they are needed, and metadata. And then the next stage is to use your vocabulary in your project software, database, or user interface, or publish it. So what are open source tools and software that are available for vocabulary creation and management? Fortunately, there are many. I will give two example scenarios which tools can be used and when. First scenario, when you structure your vocabulary in Excel and use tools like OpenRefine, Karma, RDFlib, or SKOSplay to convert your Excel data into SKOS format. Some of those tools require basic training on how to use them, but still they're very easy to use, except RDFlib, which requires programming skills because it's a Python library for converting data to RDF, and since SKOS is based on RDF, it can also be used for creating SKOS records. And the second scenario is to use SKOS editor software and enter terms and their definitions in user-friendly interface. These tools include IQVoc, Vocabs Editor, Vocbench, Thematress, Themas, and SKOS repository Skosmos. They allow to create and link concepts and provide some management functionality and database storage and collaborative editing features. Besides those tools, there are additional tools for validation and visualization of SKOS vocabularies, such as SKOSify or SKOS testing tool for validating SKOS structure and syntax, and SKOSplay for creating visualizations for your vocabulary. And now, at the end of this presentation, I would like to leave you with a few practical tasks for testing your understanding and knowledge of vocabularies and SKOS. The first task is to create a small music style vocabulary, model it in SKOS, add labels in other languages, add documentation, and maybe add links to the LOD resources, and eventually save your vocabulary in a TTL file. And in the second task, you can try to visualize your TTL file in SKOSplay tool, which is available online, and try different visualization styles for it. This is all about the control vocabularies and SKOS standard that I wanted to present you today. Here is a list of reference resources that were used and mentioned in this lecture. Goodbye, and thank you for watching this presentation.